Systems and Agricultural Engineering Department at the University of Kentucky. I'm actually stationed off away from campus about 200 miles west in a location there you see on the screen in Princeton, and I'll show that coming up. But today we want to talk about grain storage management, particularly an integrated pest management approach, which minimizes the use of pesticides as much as possible. And we use the acronym SLAM, which stands for Sanitation, Loading, Aeration, and Monitoring of Grain and Storage. And along the way, I'll talk about some new technologies that are available. Let's see. Here I'm having a little trouble. There we go. All right. So a quick look at the station where I work. This is, again, is the offlying station in Princeton. It's the University of Kentucky Research and Education Center. This is a drone shot. It looks kind of like a virtual shot, but it's an actual drone shot. If it were taken today, you would see nothing but white, much like you there in New York. But we do have about 1,700 acres. We do have crop research, grains and tobacco and forages. And the station itself is, we have about 8 different departments represented, about 14 faculty members, and about 50 support staff at the station. It's a good place to work. And if you're ever in the area, I invite you to come in and give us a visit, a look around. So in keeping with the grain school theme, I thought we would do a little bit of background work and lay some groundwork on Grain Storage 101 topics today to give us a little taste of some of the basic requirements and relationships between grain, insects, and the way grain interacts with air, those kinds of things. We'll take a look at that first. And then we'll move more to the meat of the program, talking about sanitation, loading, aeration, and monitoring each one of those pieces separately. I do want to talk about safety considerations towards the end of the program. I know Aaron's going to show some videos on that, and I certainly encourage you to look at that. It's a very important topic, obviously. And I'll close with some resources that are available around the U.S. So Grain Storage 101, we know that grain will not improve quality during storage. The best we can hope for is to maintain the quality of the grain, regardless of the grain we're holding. And early on, what Aaron didn't tell you, I started in 1975. I wish I could tell you I was 20 when I started, but that's really not the case. But anyway, so when I did learn early on about the important factors of grain storage management, my professor always puts moisture content first, and he gave it 4 stars. That's the most important factor, and we'll see why as we go along. But certainly moisture content impacts the storability of the crop, and we'll take a look at different crops as we go. Temperature is certainly also important. As maybe in comparison to moisture, maybe secondary, but it's very important. Initial condition of the grain coming in off the farm or off the combine, out of the trucks. If it has a lot of broken material or foreign material, it won't store as well as it would if it were clean, obviously. So we talk a little bit about that, and I think Aaron has some videos later in the program today or next week to talk about grain cleaning, and that is a very important topic, especially if we're going to hold grain for a long period of time. Oxygen availability is not so much a concern unless we're storing it in a silo bag or in a hermetic storage container. So we're not going to talk a lot about that, but it does impact the storability. And if we do have a tightly sealed structure, we can limit the oxygen availability to the insects and mold activity in that structure and thereby control their growth and proliferation. So first topic, again, kind of getting into introduction, is to talk about the allowable storage time, or engineers refer to this as the AST for different grains. And we're working on other charts for other grains, but we just kind of take a look at it as an example. If you can see towards the middle of the slide here, New York in September, we're going to see around 60 degrees. If you're harvesting corn at 20%, you can see that you have about 29 days to get that crop dried quickly, hopefully quickly, before it starts to go out of condition. And the threshold for that is 0.5% of dry matter loss. This information was generated by the American Society of Agricultural and Biological Engineers. I'll share some other data from our group, professional group I've been associated with my career. but it gives a lot of good information on some of the basics we're talking about today, and it's a good resource for you to, and I'll share a link with that website towards the end of the program. But it gives us a guideline, and as you look, so as I said, up in your latitude, others along that line, we'd have about 30 days, 29 days if you're harvesting corn at 20%, and it's at 60 degrees. Now in Kentucky, we would be a little warmer than that, closer probably to 70 degrees. And so we only have about 16 days to dry the crop and get it dried down. But as you can see, just comparing the columns from right to left, you actually double the storage time by a decrease of 10 degrees in temperature. And this relationship certainly is not linear as you look across the individual rows of moisture. But the idea is if we have grain that's in poor quality, especially, we want to get it dried to 16% as quickly as we can within a day or two to save ahead of any problems that might occur. And some of those problems, as we're shown here, where you might have some mold on the corn coming in from the field, or you might have some insect activity during the storage period. If this is occurring during storage, we're likely to have some heating, and we're going to talk about temperature monitoring later. But if you have some heating detected in the bin or in the storage structure, there's a likelihood that there's some insect activity or mold activity going on. You need to try to cool that out. Some of the problems that can, when it goes unnoticed for very long, you can have some weight loss, dry matter loss from their activity. You can have decreased germination. If you're holding the grain for seed for the farm, then you're going to have a problem with that. Mycotoxins are our biggest concern. Certainly aflatoxin gets a lot of public publicity. It's one of the most most concern of mycotoxin groups. And at 20 parts per billion, obviously, you might get a load rejected, or you might have discounts on that. But other discounts for infested grain that we're seeing in Kentucky, and I suspect we'd see similar there in New York, would be about a nickel per bushel. If it's infested, you may get the load rejected entirely if we have live insects in the load. And that has happened. I know some people that's happened to here. If you have some musty or sour odors of the grain, then you're likely to get a 10-cent discount per bushel. And we want to talk about ways to get ahead of those. Obviously, if you have some malodors, you have other problems going on. So we know ways to control insects is to control the temperature. Insects do like a warm temperature. If you kind of focus on this second row there, if we can cool grain at 40 degrees well below 60 as quickly as we can in the fall, it's going to start controlling insect growth and insect activity. And then we'll want to continue cooling it in the fall on into about 40 degrees or maybe a little lower. And we'll take a look at some specific numbers as we go. But the reason, of course, is that at cooler temperatures, insects aren't going to be as active. They're not going to, populations won't build up in the bin or in the storage structure. On the side of moles, they like warmth, but they also like humidity. And you can see just kind of a list here of Aspergillus group, and they tend to like it, especially Aspergillus flavus, which is the one that's most associated with aflatoxin on the next to the last row. That and Penicillium, they like a pretty humid environment. But the take-home message on this one slide is if we can control the humidity in the storage environment to 65% or less, we will do a good job of controlling mold activity. And so that's the two take-homes there from insect and mold activity, cool temperatures, dry conditions. And so what we want to look at next is the equilibrium properties for corn. And this is basically generated from ASABE data, but over the years we have charts for other grains. If you focus, just kind of look on that 65% humidity column there, you can see at different temperatures what the grain will settle out to as it's been exposed to these conditions for extended periods. In other words, at 60 degrees, at 65%, if it was dry in the field, the corn would dry to 14%. Generally, it's not going to dry that low until quite late when you get those temperatures. But earlier in the harvest season, and again in Kentucky, we're going to be a little to the right of that column. we can be anywhere from 80, 75, 80%. So the corn wouldn't dry to past much below 17% in the field. That means we need to do some artificial drying to get it dried. And I know Sean Schaus is going to talk more about drying systems next week. So hopefully this gives him a little bit of an intro on some of those, the importance of the need to talk about these relationships. So what I'm going to look at next is kind of focus on these 3 columns and the interaction of temperature and moisture. So what I've done is taken those 3 columns again. The middle line you're seeing on this plot is a 65% humidity line. And in the wintertime, our average temperature around 35 degrees here in Kentucky, would be to the left of that a little bit in New York, of course, maybe 25, 30 degrees. But the take-home message here is that we can store corn at 15.5, 16% in the wintertime. But when we think about storing it in the summer, it really needs to be down closer to 13% because the humidity in that space then would be about 65%. If we're holding corn at 15%, you can extend that line. In the summertime, you'd see it would be well above the 70% humidity line, and we would be at risk for some storage problems. So we have these, as I said, we have graphs for other grains. In the sake of time, I'll just go quick to the chase here on looking at the recommended storage temperature, storage moistures for different grains through the season. In the fall of the year, we can hold a little higher humidity. Going into the summer, obviously needs to be lower moisture content to keep the grain in that space, or the humidity in the space at 65%, and that's where that comes from. So 12% for beans, 12.5 for wheat, and if you're going to store in the summer. And you need to think about that from an economic standpoint. And again, this is kind of closing out the introductory part of the talk, but and I could use higher prices in this right now, but basically about a little over a cent per point per dollar of value, grain of cash value or market value of the crop. So if you're holding corn at 13%, it's going to cost you about 9.4 cents. If it's $4 corn, it's that weight loss and moisture is going to cost you about 9 cents. And you need to take that into account as you're planning your not just the storage, but also how long to store it and the cost of storage, not just in drying, but also in shrink. And obviously for soybeans, it gets deeper in your pocket because of the value of the crop. But again, this is think of this as a cost for controlling the microbes, the insects in the grain during storage, and that's, I think, justified. Again, compare that to the discounts that we saw earlier, and you can come out ahead with good management. So this that leads up to the talk then on storage a little more deeply. We want to talk about well, obviously the need to check moisture and temperature going into storage, and that will give us an idea of the allowable storage time of that crop. Again, we want to minimize the broken kernels of damage coming off the combine or through our handling systems, so we have grain in good condition going into storage. If we're selling grain to livestock producers or feeding it ourselves on the farm, we may want to screen that grain for mycotoxins, especially if it's been stressed in the field and we suspect there may be problems. We want to get ahead of that and use that corn, or maybe dry it a little further. If you dry damaged corn a point or two below the recommended level for sound grain, you'll have a little longer storage life in that crop. It's a good idea to clean grain, and I know again we talk. I think Aaron's going to show some more, or have more information on cleaning systems, but really again just leads up to the importance of talking about SLAM, sanitation, loading, aeration, and monitoring. And I've got about 5 slides of each one of these pieces that would go into to cover them thoroughly. So on the sanitation piece, we want to certainly look at all the equipment that the grain is going to come in contact with as it moves from the field into storage. So that means the combine, grain carts, trucks, any handling equipment. We want to clean that out prior to harvest and remove. I like to use a wet dry vac to remove loose grain from the corners of the augers, take the housing off the corners of the screw augers, for example, or U-trough augers, and get the grain out of there, especially if it's been sitting there for a while, it's likely to be infested. It needs to be removed so it won't contaminate grain coming in. Dryers, bins have a lot of ledges on them, need to be cleaned. Loose grain needs to be removed before harvest. You look at the picture on the left here, that's kind of reminds me of situation we had on the farm here, where we asked members of the farm crew to go clean the bin, and end of the day we went to check and said, yeah, we got to clean. Well, that's kind of what we saw, was a lot of residue still down along the cracks and crevices of the floor, and we had to go back in there and not with a sweep, with a broom, dustpan, vacuum, to get all that material removed. So when we're talking about cleaning, we're talking about getting all the residue out. And as you're doing that, I think it's a good idea to look around the bin to see if there's any daylight coming through. You may have any pinholes you need to seal up, so you will get some weather coming in that can re-wet the crop once it's been dried. And when you're looking around the bin itself, I've seen some areas around the roof vents where a lot of bees' wings will collect, and you want to get up there and brush those off so they don't have a lot of rust, and which can lead to a leak in around those roof vents, another area. So we obviously want to clean up any spilled grain, not just prior to harvest, but day to day during harvest. We want to be sure we remove and control weeds around the bin. Obviously, these can be a place where rats and mice like to build a home. And if they're close to the bin, not too far away from the cause a problem. And you can see, maybe you can see on the right there, that slide is showing about 3 entrances to some rat holes that were formed just actually I took that picture in January. It was a little bit milder weather, didn't have snow on the ground, but there was a lot of rodent activity around that one facility I was visiting that day. And need to have some mouse traps sit around, or some other devices to control rodents. Want to talk about a little bit about as you're pre-harvest, looking at the facilities, be sure that there's no settlement of the fans. What I'm showing here is these are in good shape. Good examples of what we like to see is tight connections between the transition, the fan, the transition to the bin. It's not unusual to see a little bit of a break or a separation or a gap in some of those joints. You want to look at those and seal those up. Otherwise, you're going to be losing some airflow out of your drying or aeration system. If it's a very big gap, depending on where it is, you may want to use a expanding foam, like you might use around the house, to seal up the cracks and crevices to weather tight, keep from air leaks from coming in. A couple of other areas that you want to pay attention to before harvest, again, is take away some of the covers. The picture on the left, I don't have inside, but there was actually the rubber sealant around that box had broken. And when we opened that box, there was a lot of bees' wings or cobwebs in that control panel of the dryer, and that needed to be cleaned out and removed before harvest. Otherwise, you get some, you might have a fire hazard if some of those get in some of the solenoids or the contacts in the box. But likewise, to the right, we're looking at a mechanical drive system for the unloading auger. There's a lot of debris that's built up, and dust is built up, and that needs to be cleaned out so you don't have any problems with wear and/or you just want to be sure the equipment is going to perform reliably during harvest. So that just wraps it up for the sanitation piece, and moving on to the loading points we want to talk about. We were on a farm one time to collect some grain samples, and we thought we might have room to work around and get a lot of samples around the grain. But actually, when we threw open the hatch, we saw that it's quite full. We couldn't really take much very representative sample. But we'll talk a little bit more about this. But you don't want to overfill the bin is the point here. And obviously, you have a big crop. It's not unusual to have bins this full, and it's okay on the short run, but in the long run, you want to core those bins. And along the way, you want to be sure and and manage the trash and the fines. You want to control the damage to the grain, set the combine threshing mechanism so that you're not getting over too aggressive threshing action on the combine, and you're not generating a lot of broken material. You want to run augers full and as slow as possible. I know Sean's going to talk a little bit more about that when next week in his presentation on the equipment side. Again, I think this is the third time I've mentioned cleaning, and again, it really goes a long way in adding storage life to grain if you're especially going to hold it for a long period or through the summer. Spreaders can be used on smaller bins. They work a little bit better on smaller bins. A lot of the spreaders we have don't work well in large bins. Unless you have a large, what we call a spider type of spreader, would you have long veins that could redirect the flow of grain coming off the spreader. There's another way to handle that, and that would be to core the grain, not to use a spreader, but to core the bin after it's been filled to remove the trash and fines. And I have an illustration of that as we go here. So this is looking at a bin that has not been overfilled per se, but it does have a lot of trash and fines. This will be an example where you have a bin has been filled with just a spout, not a spreader. You have a concentration of fines you can see in the center of the bin there. And what we have, as you know, as an engineer, air flows and follows a path of least resistance. And so along the wall, it's not as deep. We have loose grain. We have not as much resistance to airflow in that spot. So air is going to move through that when we're cooling it, when we're drying it. Air is going to move through those sections quicker than it does through the middle, especially in the very center where we have a lot of fines. We have that material is actually blocking the airflow, is creating a lot of resistance. We also have a deeper stack of grain in that area, so it's going to take quite a bit longer. It can take twice as long to move an aeration front through the center core if it's not removed. So to illustrate the point here, this illustrated animated slide shows to remove the top center core, about a third to a half the diameter of the bin. And it's going to do several things for you. It's going to obviously reduce the height, give you better airflow in the head space, better ventilation in that space, which is important. It also removes that center core of fines and lets you handle them elsewhere, put them in another spot, move them to another area of the farm. It improves airflow, obviously, in that center of the bin, and it does provide space for monitoring grain. So for small bins, you can do that at the end of after the bin is filled, or maybe part way through the harvest. But for larger bins, we want to core them on a more regular basis. And talking with farmers that have, I'm talking 50,000 and larger bins, you want to core those on a daily basis. You have so much material to deal with is the reason for that. Next thing we want to talk about then is aeration. And this animated slide illustrates the flow and when you're pushing air up through the grain, it takes some time to get the job done. So the rule of thumb is for the aeration time is to divide 15 by the fan capacity in terms of CFM per bushel that's in the bin. And we'll talk a little bit more about that. But in the table here, the minimum airflow rate that's generally recommended for aeration systems is 1/10 of a CFM per bushel. And that's going to take you about 150 hours of total fan time to get the grain completely cooled. Compare that to if you have a larger fan, you may have 1 CFM per bushel. It'll take you proportionately less time to cool the grain, so 15 hours then. And in that case, you might want to pick the times when you're running the fans. You can run them intermittently. We'll talk a little bit more about controlling those fans and automation controllers. But if you're running smaller fans at 1/10 of a half a CFM even, I think you probably want to try to look ahead at the weather and pick a time when the temperature band is in the target range that you desire, and run those fans accordingly. So to look at some weather data for New York, here's the average max min and the average monthly temperatures for, I think this is for the Cornell area. So actually the blue line is the maximum. We want to focus on is that red line in the middle, and that's really what we want to kind of target. Or it's probably a good idea to stay below that if you can, and take advantage of the cooler weather as much as possible. So I'm going to add on some boxes here to indicate the target temperatures that we like to see during the storage period. So after we've harvested early September, we want to cool the grain down to about 55 degrees plus or minus. And then along about early October, again, cool it down to about 45 degrees plus or minus 5. And then in November, cool it on down to about 35 degrees, and then hold that through the winter and seal the fans actually, so we don't have as much of a chance for wind-blown air current to come through and rewarm the grain. It looks a little off the averages, but again, if we can keep it within 10 degrees of the average temperature, that's a general overall rule of thumb, and it would apply then for New York. But again, if you remember the target temperature we have for controlled insects, it's about 40 degrees or less, and we'd be in that range, and we want to just try to keep it as cool as we can. And I'll show a slide here after this one to illustrate what that would look like in an extended period of time. But after we've cooled it out, we want to seal the fan either with plywood or metal cap, or use a heavy tarp and a wire to seal that fan, so again you can block any air wind-driven air currents from going through and rewarming the grain at the bottom, and if we're holding it into the spring. So the illustration shown here is actually some research that's been done to look at the changes of temperature and moisture in a large silo. This is 135,000 bushel structure. The simulation was actually performed in southern Indiana, and you can see the profiles that we're looking at here in late July, and the simulation data they used was in 89, which I think would be fairly typical. They used a typical weather year. But what we're looking at on the left is a temperature bands, and it's a cross section of the bin. So that vertical line, the y-axis is actually the center line of the bin. And as you go out towards the outside of the tank, you can see actually we're getting quite a bit of warming along the wall, but that's not penetrating into the grain surface itself. And the bulk of grain is holding at about 50 degrees or about 45 in that center blue line or blue area, the center core. And even towards the wall, it's not getting much over 70. So we're getting good temperature control in the bulk of the grain. And the overriding point here is to the right is the moisture profile in that same structure. And this is a 60 by 60 bin. And again, you're looking at half of the other structure, but we're not seeing increases or changes in the moisture content of the grain. It's shown in the right side of the right graph there. So this is why we say that it's a good idea to seal the fan and keep grain as cool as you can going into the summer months. So how do you know how much airflow you have? Well, there's a good program from the University of Minnesota that the website is shown there that would indicate the type of, well, for the size of bin you have, the type of grain you have, the type of fan you have on that bin. There's 400 fans selected in the library of their database, so you can just about mix and match any combination that you would have out there. And what we'll calculate is the number of bushels, the airflow, and then the CFM per bushel at different depths in the grain. So this is just a screenshot then of the input page for that program. And we're going to run an example here with shelled corn, and we'll compare that with wheat as we go. But to look quickly, then we're looking at a full floor bin, 48-foot diameter, 33-foot wall height. This is a 50,000 bushel nominal capacity bin with when it's filled to the peak. And if we specify a design airflow of a half a CFM per bushel, the program estimates that we're going to need about 30 horsepower total of fan capacity to move that much air. So I went through the library of fans. I selected two 15-horse centrifugal fans because our static pressure is looking around 5 inches per 5 inches of water. And then for the output table, you can see at 3-foot depth increments, how many bushels we have at each of those depth increments, how much CFM those fans will deliver. And then that column over to the fourth column over is the CFM per bushel. And you can see if you look at when the bin is full, we're getting a half a CFM per bushel. So we did achieve our design rate, airflow rate. In comparison, if you look at when the depth or when that bin is 18 feet deep, we have 1 CFM per bushel. So, or 1.1 to be exact. So it's going to take half as much time to run an aeration cycle through if that bin is only half full. And then if you compare corn versus wheat, or ran a simulation then to compare that, and you can see on the bottom row at 30 feet of depth, corn gives you a 6/10, you can get 6/10 of a CFM per bushel with those fans for corn versus 0.3 for wheat. So you're looking at 25 versus 50 hours of fan operation to get the cooling cycle all the way through the grain. In terms of costs, we'll look at 3 different aeration rates, 3 different cycles in the fall. And so the minimum airflow rate, it actually only takes about a 3-horse fan on that large bin to get a 1/10 of a CFM per bushel. If we have 3 aeration cycles, we have a total of 450 hours. And at 10 cents per kilowatt for electricity, it's going to cost about 3/10 of a cent. And it'd be the same for a 7.5 horse fan if we had a 1/4 of a CFM per bushel. And if the example I showed, if we have 2 15-horse fans or 30 horse total, half a CFM per bushel is going to cost us about 6/10 of a cent per bushel just to cool that out in the fall. Again, this is 3 aeration cycles, but you think about how that compares with, if you have a nickel discount for insect activity, then obviously this is very affordable insect control by just controlling the temperatures. So how are we going to know where that front is? Well, we can actually use temperature cables to track the movement of the cooling front through the bin. In this particular example, showing kind of an older style plug and play type of temperature cable system. These temperature cables have monitors or sensors about every 3 feet down along the column, and those cables extend almost to the floor. And during the storage period, obviously, as the bin is unloaded, the sensors up in the air will have a different temperature than the temperature down in the grain. And the more modern systems, you can fully automate those cables, or you can access the information with a computer or your cell phone. So as the example that's shown here is the red dot is obviously showing and illustrating a hotspot in the bin, maybe due to insect or mold activity, and would cause well, you want to react to that and run the fans to cool it out. Or if that won't take care of the problem, if it's a very large problem, you may have to move the grain to another bin to just turn it so that you can break up that hotspot. In terms of insects, I'm just going to touch on this briefly. I know Ken's going to go into more depth on insect identification here in the next talk, but you can use some handheld system or handheld tools, either a pit trap or a grain probe to sample grain in the bin, and then take that out maybe to a shop and sieve it out, look at the samples more closely to see if there's any insect activity, or you can use a handheld. This is much like the temperature cable systems. It's kind of a plug and play type device where you have these pit traps inside the bin. They have electronic monitor at the base of them, and then you can plug the cable into the base of the bin and see what the activity was last time you had checked it. And of course, you can guess that then these systems can also be automated fully, where you can actually access and transfer that information on insect activity then to a computer or a handheld device. I wish we were able to have the Farm Machinery Show. I don't know if any of you have ever been to the National Farm Machinery Show in Louisville, Kentucky. It's generally held, actually it would have been held last week, typically the second week in February. But some of the devices I'm showing here would be showcased at that type of show. And there are other farm shows, of course, around. But the STEPS GMS device that you're seeing on the upper left there is a fairly simple aeration device. It's just based on temperature and humidity of the air. And you can use the equilibrium chart then to know when you need to run the fan to achieve the desired moisture levels in the bin. And so you wouldn't necessarily run the fan when it's going to re-wet the grain, although You may if it's over dried, but that's a different topic. But the other devices that you see here, and again, I'll share some of the the information, or the websites are shown there actually, and they have different levels of sophistication, whether it's just monitoring temperature and humidity of the airstream, making a decision on when to run the fan, or you may have to use more sophisticated devices for taking the next step and making those decisions for you with your programming. Another device I wanted to emphasize here, and I'm getting close to time, so I have to speed along here, but it's a CO2 monitor. These are quite effective and can pick up a problem maybe before a temperature cable would, or a temperature sensor might, because unless that hotspot is really close to the sensor, it may take some time to actually penetrate and actually be picked up by the sensor. Whereas for a CO2 monitor, you can generally pick up elevated levels of CO2 more quickly than you would a temperature increase in the bin. So I want to encourage you to look at that. Just a list of some of the devices that are used for monitoring temperature and humidity in the grain or in the air. The one on the upper right is just a small digital $5 device that you can get. It's a hygrometer that you can get. You know, they sell those at box stores, online. Amazon have those. The other device I want to share with you quickly here is that one is in the insert in the upper right. Is called an Amber Ag. They're testing this. I know at Iowa State they're doing some tests on this to throw this as a thumb size, basically a pellet that would go into the grain. They put it in one pellet for every 1,000 bushel, and it monitors temperature, humidity, and it emits that information, so you don't have to have a cable to in the bin to monitor conditions. In terms of cost to install these systems, it's fairly affordable, especially if you've had any heavy discounts over the years. But cables themselves, anywhere from a nickel to a penny and a half, half a cent to a penny and a half per bushel, looking at the life of the system. Fan controllers will cost you a little more. Aeration systems that are sophisticated would cost you quite a bit more, but at the same time, it takes a lot of guesswork out of knowing when to run the fans. I need to spend at least 5 minutes talking about safety. I know Aaron's going to show more details on this, but we all know that safety is an important consideration in handling and storing grain. Picture on the right here shows, I guess, how we used to do it. These folks were getting geared up for a fumigation application. And the fellow on the left is really illustrating what we would like to see more when you're climbing in a bin. Is you have a climbing harness, you have devices where you can attach that harness to a secure structure when you're climbing in the bin, as well as once you get on top of the bin, you'll be secure. Obviously, also not shown here is you want to have some dust protection, and we'll talk a little bit more about that. But I want to share quickly a rescue of a fellow that was trapped up to about a little above his waist, not quite his full chest, but was trapped inside a bin near our office some years ago. And they called 911, had all manner of emergency vehicles coming around the farm. They cut some holes in the bin to relieve the pressure from that victim. They removed him from the bin on the backboard that you see on the bottom right of that hole that shown in the bin. This is not a real large bin, about 6,000 bushel bin. But after all the kind of commotion had settled down, I slipped around and took a picture of of what actually caused the problem. And they had a large chunk of grain that had gone out of condition in the center of the bin and had blocked the flow, and that was what was causing the problem. Now, this story is easy to tell because the fellow was sent to the hospital, got checked out, was home that night having dinner with his family, was not injured. But the other part of this I wanted to share was that you can see the grain that was around that large chunk was in good condition. But again, this was in 2005. We didn't have the tools that we do today. One thing they could have, I think, that could have saved a lot of problem would be what they call a cofferdam, and I'm going to share that real quickly. A lot of local EMS outfits have these in storage and in use. If you're in a bin, you may want to let them know about the activity that you're on the farm and have access to a cofferdam. You could build one out of plywood or sheet metal. There are some plans available to do that. There are some available commercially, but these generally are um, very similar in design and construction, where they're built in 4 sections that can be taken into the bin and then assembled and inserted around the victim that would be partially submerged. Then you can remove just the grain around the victim, and then he or she could extract themselves from the grain without so much effort. So a quick list of some of the cautions and some of the steps to take when you're going into a bin to inspect. And I know there's obviously a $5 corn, you got 10,000 bushel, there's a lot of money represented there. And it behooves you to check on that grain frequently. So if you do that, you need to shut off and lock out and tag out the unloading equipment. You want to be sure and use a respirator to protect your lungs from dust and mold spores. Use a climbing harness, a safety line that's again secured to a solid structure in the bin. And you want to have somebody positioned outside to monitor activity inside the person that's inside the bin. Avoid the center if you can, and then have a cofferdam on site. Some of the engineering departments that I'm familiar with that have active programs and post-harvest management shown here in an alphabetical list, and websites for those, and quickly share then some other organizations. One, NC 213 there is a consortium of engineers, plant pathologists, entomologists, ag economists, and others that deal with post-harvest management and maintaining quality of grain post-harvest. So those resources are available. And then if you've not seen the Midwest Plant Service Handbook on Grain Handling, Drying, and Storage, that's another good resource for you. But that does conclude the comments I had. I know I'm a little over time, so I apologize for that. But I think it can open it up now to some questions, Aaron. We can take it from there. Thank you for your attention.
That's good timing. Thank you very much. We do have a question in the chat.
Mm-hmm.
Let's see here. I guess I don't see it now, but the question, well, let me
We've got a hand raised too, Aaron.
yes. So Sarah's question was, does does it matter about grain variety and how well it stores in the north compared to the south?
Well, again, this is why we want to go through the basics, because if you adhere to the moisture and temperature limits that I described there, that will control the biological activity in the structure. So it's more predicated on environmental conditions within the bin. So again, the threshold is 65% humidity. You can measure that uh, fairly easily. And if it's below 65% humidity, then you have safe storage conditions for controlling molds. If you control the temperature 40 degrees or less, you'll be in good shape to control insect activity. So
Okay.
it's really not it's not dependent on the type of grain. Those environmental conditions apply to all grains.
Okay. And different, like we have hard kernel and soft kernel corn, although soft kernel is really for silage, but
Mhm.
it might take more effort or less effort to get to those standard conditions depending on the grain, perhaps.
That's where you get into, yes, sir. The different types of grain will have different drying rates, based just the physical properties of that material uh, can have a
Yeah.
little bit different
Okay.
um, impacts on drying. But the bottom line is, I think if you adhere to those environmental conditions, and it does tie then to the equilibrium moisture properties for that crop, and that can vary a little bit, but yeah, for the soft kernel versus hard kernels, but
Yeah.
most of that is really related to the drying rate. I think Sean might talk about that next week
Yeah.
a little bit, but
Okay. So I'm going to ask my question. Um, when and how do we aerate the headspace of a bin? Like in the summertime, if it starts getting hot, how do we manage that?
Yeah, good question. So you want to be sure that I didn't talk, I really went through this pretty fast. I didn't have as much time to talk about some of those nuances that I would like to have had. But you want to be sure that you have enough roof vents for starters, and you want to be sure that they're not blocked. And that's why, that's one reason we don't want to overfill the bin. But if you have a good headspace, uh, a good cavity, a good open area in the headspace, you want to be sure. I mean, wind-driven currents are going to ventilate that space pretty well on its own. If you have extended periods of stagnant air, which is a little unlikely, but I know some commercial elevators, they actually use a power vent. They'll put a fan on one of those vents and do more active aeration in the headspace as opposed to the passive, which would be wind driven. But you should have, I mean, if you have enough vents to start with, you generally would have fairly good control of the headspace ventilation just with natural air movement.
Okay. Well, thank you, Sam. That was very good. So we're gonna now have Ken Wise give his presentation. So Sam, you can
Yep.
stop sharing, and Ken, you can put your presentation up. One thing I want to mention is that, we're talking a lot about bin storage, but the principles are really all the same, whether you're storing in 50-pound sacks or, you got a gravity wagon you're using for storage. All these principles are really applicable. You just have to learn how to apply them to your type of system.